Hello and welcome to section 11.4. I'm going to be talking about the Pythagorean theorem today, and the reason why this is in with our chapter on square roots is because, well, the Pythagorean theorem has the square roots, or a lot of times we use square rooting to solve the Pythagorean theorem. And I'm going to talk a little bit about what that is in case you guys haven't seen that. Here is the answers for 11.3 day 2 in case you guys haven't seen them. So like I said today, we're going to talk about the Pythagorean theorem and its converse. Probably don't know what the word converse means. You'll learn about that in geometry. Alright, so what the Pythagorean theorem is we take a right triangle. A right triangle is made by, it's just a triangle, but it has a right angle. The two sides that make up the right angle are called the legs, and the side opposite of the 90-degree angle is your hypotenuse. So it is a squared plus b squared equals c squared. So we take leg squared plus leg squared equals c squared. Doesn't matter which one's a and b. No. Doesn't matter which one is c. Yes, c is the hypotenuse. It's the longest side always. Here's a video. If you guys want to type that in, you can check that out, or I can show you guys in class a little demonstration on the Pythagorean theorem. There's tons of little things that you can do to Google it. But I'm not going to show that in the video. I'm not going to prove it. I can show that to you guys in class. I'm just going to solve some problems for you. So we're going to find the missing side here. A squared plus b squared equals c squared. So let's go with a squared plus 36 equals 49. I can subtract the 36 from both sides. That leaves me with 13, and then square root both sides. A equals root 13. I'm going to leave it in simplified radical form. Sometimes a radical will simplify, sometimes it doesn't. Now, as we learned earlier, when you square root both sides, you usually have positive and negative root 13. Well, the reason why we don't have the negative version is because we're talking about side lengths, and side lengths are never negative, so we throw that out. Alright, let's go with 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. This one's a little bit nicer because you don't have to solve. It's already c is already on its own side. So, and sometimes you end up with a square root, sometimes you don't, or sorry, a perfect square, and sometimes you don't. I'm going to do a problem that we could actually simplify. I got this one over here, put in simplified radical form for you guys. So when I subtract the 90 of 40, and we'll square root both sides, so I'm going to get root 4 root 10. So 2 root 10 is going to be my answer in simplified radical form. That's something we learned how to do earlier in the chapter. Okay, so that's that. I'm going to go through a couple more different types of problems here. This one doesn't give us a picture, but it says it's a right triangle. One leg is 2 inches longer than the other leg, so we're going to call that x and x plus 2. And the hypotenuse is root 10. So we're going to square the x. We're going to square the x plus 2. It's a binomial squared. We're going to square the root 10. So x squared, and then the binomial squared is going to be x squared plus 4x plus 4, and the square root of 10 squared is just 10. All right, we're going to simplify up here. Add those two together. X squared plus x squared is 2x squared plus 4x, and then I'm going to subtract the 10 to get everything on the same side. And we'll divide by 2. This is just solving a quadratic, so using some of our techniques from chapter 9 here, making the numbers a little bit smaller. And then we'll solve this using factoring. X plus 3x minus 1. Alright, so my two solutions are negative 3 and positive 1. But you'll notice when you plug in negative 3 in for x here, that makes that a negative side length, so we're gonna just toss that answer out. We're gonna go with x equals 1. These types of questions are very common. They're gonna give you a word problem. They may or may not give you a picture, but you're gonna have a right triangle, and you can just call that x and set this up using the Pythagorean theorem and then solve it. I'm not gonna solve this because all these problems are pretty much the same. Here's your answer if you do want to look at that. Same with example number 2 here. You got a swimming pool 30 by 60. You swim across diagonally. What is the length that you swim? Again, you can just use Pythagorean theorem there. And then the converse of the Pythagorean theorem is determine whether or not a triangle is a right triangle based off its side length. So you can just do a squared plus b squared, and then see if that's equal to c squared. If these are equal, then it's a right triangle. If they're not equal, then it's not a right triangle. Just make sure c must be the largest number. So keep that in mind. And then, yeah, that's pretty much it. That's all I got for you guys. Yeah, so that's the Pythagorean theorem. Thank you guys for tuning in, and if you guys have any questions, please let me know.